So the Common Core today, it is A for algebra, and basically it's APR, polynomial roots. It's algebra, but polynomial roots. Okay, so in section 3, which says identify zeros of polynomials. And that's exactly what we're doing today. 2, 13, 17. Okay, now here's the trick. There's lots of ways to find zeros. Lots and lots of ways. The easiest way, the fastest and the easiest way is by factoring. Okay, Elijah? Now, the nice thing about the first example, it's already factored. Don't mess it up. Don't start multiplying it because it's already factored. So this one's already factored. So if it's already factored, most of the hard work is done. So if you want to find zeros and roots are kind of the same thing. We're going to talk more about roots later. We're going to get into i's. Remember imaginary numbers? We'll start talking about those tomorrow. And we start to get real zeros with i's. We start to call them something different, called roots. But for right now, let's just call them zeros, okay? So if it's a 0, all we do is we set it equal to 0. If it's a 0, set it equal to 0. It's already factored. We know there's 3 answers. We just have to solve it. 0 equals x minus 2 and 0 equals x minus 3 and 0 equals x plus 4. When I solve, I'd get 2 for x. When I'd solve, I'd get 3 for x. And when I'd solve minus 4, I get negative 4 for x. Now, all 3 of these are zeros because we know that 0 times anything is 0. So if we go back to the original question, if I put in 2, I get 0. It doesn't really matter what the rest are because 0 times the rest is still 0. If I plugged in 3, I'd get 0. It doesn't matter what the others are because 0 times any of these other 2 is still 0. And one answer is negative 4 because I plugged in negative 4 right here. I get 0. And 0 times the rest of these is 0. So it doesn't really matter. We need all 3 of them will create the zeros. They're also going to be, if they're real zeros, they're also going to be x-intercepts. So you'd have an x-intercept at 2, you'd have an x-intercept at 3, and an x-intercept at negative 4. The polynomial, if you want to graph it, might look something like that. So zeros, x-intercepts, if they are real numbers, they're real numbers, whether a fraction, decimal, whatever, even a square root number, if they're real, then they're also going to be x-intercepts, okay? Tomorrow we'll look at ones that are not going to be real, they're going to be imaginary, okay? All right, example 2. Well, it'd be nice if example 2 is factored, because if it's factored, then we can do a lot more with it. So in example 2, we're going to try and factor. So all 3 have a common x. So let's set it equal to 0 because it's called a 0. And then we're going to start factoring. So what I notice between all 3 of these terms, they have a common x. So I'm going to common factor out the x and then compare and find out what's left over. So this is an x cubed. So if I take out an x, I'd have an x squared left over. Minus, take out an x, I'd have a 2x. Take out an x, and have a negative 8. Okay. Now, I know there's got to be 3 answers. So I should be able to factor this one again. And I can. The multiples of 8 can be 4 and 2. If I do a negative 4 and a positive 2, it will make my middle term of 2. Okay? So this trinomial factors. Let's do it again. 0 equals x. X and x, right? Just like we just did. X and x. And then what times what makes 8? 4 and 2, right? Let's use a negative 4 and a positive 2 because they will multiply. They'll multiply to make the negative 8, but they'll add up to make the middle term of negative 2. Of course, we're not done yet because we need to solve it, but we are going to get 3 answers. One answer is 0 equals x. The other answer is 0 equals x minus 4. And the third answer is 0 equals x plus 2. Okay? Almost done. This one's already solved, right? 1, 0 is 0. Plus 4, another 0 is 4. Minus 2, and the third 0 is at negative 2. Okay? So, before I go on to 3 and 4, I really need to make this pitch, okay? Guys, you're listening. Yes, a lot of this I'm going to show you how you can do it on the calculator, okay? But sometimes the calculator will not give you exact answers. So we got to be careful, all right? If it's a square root answer, the calculator will never get you a square root answer. However, we can find these by using the calculator. Keep in mind that if real answers, real zeros, are just x-intercepts, then if we graph this, we should be able to find the zeros from the calculator, right? So if we need to grab a calculator, let's take a look at example 3. Oh, thanks, Marie. Okay. That's what I want anyway. This is mine. So let's take a look at it. So in example 3, let's go ahead and go straight to y equals. Everybody have a calculator? Okay, do you need a calculator? Nope. Okay. You want to give it over? We can pass over to the girls if you don't care. Okay. So y equals, and I'm going to type in 3x to the 4th plus 4x to the 3rd minus 7x squared minus 2x minus 3. Now, before I push graph, this problem could have 4 answers because of the x to the 4th, okay? It could. It might have less, but it certainly could have 4 answers, all right? Now, if I graph it, I may have to change the window a little bit. If I graph it, okay, it looks like this. Okay, now it only has 2 answers. If all I care about is the zeros, I don't really need to change my window. All I need is that point and that point. See those? This one didn't come up high enough to give me 2 other answers. That makes sense. If the polynomial had come up further, I would have gotten 2 more answers. But I'm only going to get 2 zeros, right? So let's find them. So let's go to calculate 0. Okay, so go to calculate 0. Second, calculate. There's my 0. Let's find the one on the left first. So let's move the cursor all the way over. Now left bound would actually be above it. So even though it's above it, it really is left of it because it says left bound. So that cursor, so I'm going to lock it in, enter. Right bound, it's below it, but it really is to the right of it. Does that make sense? Above it really is to the left of it, and this one really is to the right of it. Enter. Guess, well, it's right about there somewhere. So the calculator, and you see the value of 0 for y. Y is 0. So it's about negative 2.3. So 1 0 is approximately equal to a negative 2.3, okay? The other 0 will do the same process. So to calculate our 0, okay? And left bound would be below it in this example. Okay, so left of this point is certainly going to be below the 0. Enter. Right bound is going to be above it, even though it's still at the right of it. Enter. And then I'm going to guess, well, it might be right about there. Enter. And again, I get a y value of 0 because we're looking for a 0, okay? So it's approximately 1.3. And approximately 1.3, okay? Now that's not a bad way to find zeros. Now, these other 2 that don't exist, tomorrow we'll talk about that. The fact that it really does have 4 answers. These 2 will be imaginary answers, which we'll figure out how to get on Wednesday, okay? So we have 2 reals, and on Wednesday we'll find out how to get the imaginaries, okay? Because they don't quite cross at all. Okay, now, let's turn the page. All right, if you want to learn a nice trick, you got to listen. This thing's called the poly button. The poly button will find the zeros very quickly. Okay, where do you find the poly button? It's in your apps. If you have one of my nice calculators, we're going to go to apps, all right? So this will always give you the zeros, the poly button. This is a polynomial. When you go to the poly button, you go to all the polynomial features. So I go to my apps. So my apps is right there. And I have lots of apps in this calculator. There's a ton of apps. They're like extra little programs. And I want to go down until I find this poly something or other. Now, all these calculators are slightly different. Mine's very old. So I'm going to go LMNO. There it is. Mine says polysmilt. Okay, and you probably have something very similar, don't you? Depending on your calculator, mine is polysmilt, okay? So I'm going to push enter. So I'm looking for the poly button for this poly smelt. And then I push enter. This is free advertisement. Aren't we lucky? So I'm going to push enter again. I don't need this. It's just Texas Instruments saying, hey, look at me. Free advertisement. Press enter again. Now, what we want to find is the poly root finder because we're looking for the roots. Roots and zeros mean the same thing, pretty much. So I'm going to go to enter poly root finder. So I want the poly root finder. Now, if you have a newer calculator, it might change slightly from the next few buttons I push, okay? So then, after I push that, I'm going to push enter. Now, I want to know the degree. So what is the degree of my polynomial?
5.
It is 5, and it's important you know because the calculator needs to know how many answers to look for. It's going to look for 5 answers, okay? So you have to tell it what degree. Degree 5, plus now it knows how many places to ask you questions. For example, it's going to ask for the 2, the 5, the 8, the 14. So I push enter. And now I'm going to put the 2 in for the 5th power. Okay, so I'll put 5 in. I put 2 in, sorry, my bad. 2 in. Then I'll put the 5 in for the 4th. Put the negative 8 for the 3rd. Negative 14. I'll go 6, and then I'll go 9. Okay? How am I doing? And then I'm going to solve. Yes, I just heard that. That's exactly right. Solve, and it's going to think. So it doesn't solve it, it looks for them. It's a calculator. It doesn't really factor. It doesn't really think. It's going to try and find them. So it's trying all these different values. It's going through, and it's going to find some answers. So, because it's just trying to find them, this negative 1.000000 really is negative 1. It really is. It does not do math. It tries to find the value as close as it can. It really is exactly negative 1. We could prove it, okay? And this negative 9999999 really is exactly negative 1, okay? Which means we have a double root, okay? So my answers to this one are x equals 1, x equals negative 1, x equals another negative 1, x equals a 1.5, and x equals a negative 3, okay? Those are all 5 of my answers. And they're real answers, which means we could have graphed them, right? Okay. Pretty good lesson. So there's a lot of this homework today. There's not a lot of problems. Some of it you can factor. If it says factor, then please factor, okay? Because on the test, if I say factor and you don't factor, you will miss it, okay? Other questions will say by using a calculator, right? So here we go. Page 283, 15, 27, 55, 61, 95, and 99.